Good morning again. So the recording automatically feature works really good, but then it records the first few minutes of me setting up and getting things set, and then I have to trim that out and edit it. So what I just did, and trying this out, is just stop the recording and open a new recording where I just welcome you after everything's set up and everybody's in the room. So you may have been prompted again that the meeting was being recorded, prompted when you joined and prompted when I just turned on and off the recording. So if so, that's the explanation right there. We're looking this week to continue our discussion of lines. And after we've done lines in every way we can think of doing them, then we're going to look for something a little more exciting, a little more variety. And if we're going to talk about formulas and things that have a little more action in them, a little more complicated than lines, then we need a different way of describing what's happening. And that's the concept of functions or functional notation. Keep bringing everybody in here. So I don't know what you've heard of that word before. If you haven't heard the word function before, that's nothing to be concerned about. I'll show you what it means. But it's a little more formal way to write a formula, or a little more formal way to write an equation. And it makes it, as we go on into more complicated graphs, it makes it easier to graph things. Just take a spin on our website for a second. We're in week 4 right here. And we're looking at these sections. Today we'll look at 3.3 and 3.5 essentially. And then more talk about functions on Thursday. You have a homework due tomorrow night, a written homework and XYZ homework. And there's the written homework problem and the XYZ homework sections. Just get a copy of this written homework problem up in front of you because I've had a couple of questions that I might be able to answer. And get this issue of a little bit of lag. I have to see how the recording works. Sometimes I get a warning that my internet is unstable, and that might affect what you hear here in real time, but the recording should still be correct quality. So I'm not too concerned about that. Let me see if I can get this going a little bit better. There we go. So this written homework you're submitting tomorrow night talked about absolute value equations and inequalities. So you can use the rules we discussed to do these 3 problems. Greater than or equal to, and then this third problem right here that you have to rearrange. But you could also think of these things on the left-hand side: absolute value 3x minus 1, absolute value 1/2 x plus 5, 5 minus the absolute value of x minus 4. You could think of those as things you could graph. And what does the graph of an absolute value function look like? Well, in the simplest case, it looks like a line that's been bent, or it looks like 2 half lines. And so I wanted you to draw those equations, to graph those things, and to see what it means to be greater than or equal to 2, equal to 4, or greater than 3. And to get you a head start, I gave you the graphs with a good scale. So you didn't have to invent or choose the scale. I just said, okay, you graph the absolute value equation on these graphs. Each one has a slightly different scale. I also graph the line y equals 2, y equals 4, y equals 3. And then you're going to see how the absolute value of 3x minus 1 relates to that. Now, we didn't draw any absolute value graphs specifically in class, but I made a video where I showed you how to graph the absolute value, basic absolute value graphs. Now, if you have a printer, you can print out the problem. You can print out my graph paper worksheet that I pre-prepared for you, or you can draw your own, but I'm just trying to save you work by graphing this here. If you don't have a printer, then you take a sheet of graph paper and you could copy these drawings. They're not take too long to copy the drawings in scale. And then you could do the same work on top of your graph, your drawings. I have a couple questions like, should we use graph paper to make graphs? And the answer is yes, always, never do anything but that. So no matter what graph you're making, no matter how simple or how complicated, always use graph paper. And if you have access to a printer, that's why I gave you the graph paper on my website under the handouts. And you can find that under the resources page. That if you don't have access to a printer, you could buy a sheet of graph paper. I'm sorry, not a sheet, just buy a pad of graph paper. And just like I'm writing on right here. And you get several sheets of graph paper. I can't remember what they charge me for this at Staples or Walmart. Get yourself some graph paper. It'll make your graphing very much faster. Oops, got to add someone else in here. It'll make your graphing very much faster and much, much more accurate. So trying to draw a graph on just plain paper, it's hard to draw the axis straight. It's hard to mark the points consistently and to make these marks on the axes consistent. It's just hard in general to make a good picture like this. So here's the plan. Do not graph unless you're using graph paper. And if you graph without graph paper, I will make a note of that. And you are being graded on the accuracy of your graphs. That will take away from the accuracy of your graphs. So don't do a graph without graph paper. Back to here. Okay, so you want to say, but how do you draw those absolute value graphs? So let me go back to my webpage, and you can find the video where I describe that, but I'll just show it to you where you find it. Under videos, under the topics list, I should put a link to it here. And did I put a link to it in the last week when we were doing it? In week 3 video, I think I have a link right here, basic absolute value graphs. These videos are explaining how to use absolute value rules, but this one, basic absolute value graphs, is the one where I showed you how to graph some absolute value function. I'm gonna turn down the audio there. So on this video, it's about 6 minutes long, I graphed 2 examples of absolute value equations that you could use to do your problems. I'm not going to shortcut the video, I'll let you listen to it, but just the quick speech is that it's going to end up looking something like a V or 2 half lines. Now I'm just trying to find at the end of the video, and got to get myself out of the way. I was out of the way a second ago. Okay, it's no good without the explanations. But an absolute value graph, a basic one, is just going to be a V shape of some kind, it's going to be like taking the line 2x minus 1 and snapping in half and bending part of that line up. That's not a good explanation. Listen to the video, hear the explanation. You can draw this absolute value graph. If you weren't sure how to find anything like that, remember you can always, week 3 or week 4, let's go back to week 4, under videos, go back to the playlist, class session videos, recommended problems, additional problems you ask, but topics. That's where I put that video. So here are the videos explaining how to do some absolute value problems. And there's the one at the bottom of the list, basic absolute value graphs. Maybe I should make those show in reverse order, but I'll do that later. Let me get someone in here.
So I do have a question.
Go ahead.
How do you want us to explain how we're graphing the absolute value graphs?
Let's go back to the problem because I don't remember saying explain how you graphed it. You just graph it by graphing points and connecting the points appropriately. This, oh, okay, so if you're referring to C, be careful what it says there. It doesn't say explain how you made the graphs, and I'm presuming you're referring to that. I may not be right. It says explain how these graphs match, confirm the answers that you got up to these problems up here. Like, I don't know what the answer is to be unless I worked it out right, but I expect the answer is going to be 2 points because the only way to win in B is to have the inside absolute value sign be 4 or minus 4. That'll give me 2 separate points. When I graph the absolute value of 1/2 x plus 5 alongside this line of 4, how do I see that the answer to the original problem was 2 points? And so for the others also. How do you connect, whoops, I didn't mean to get rid of that, sorry. How do you connect the answers to these problems to what the graph looks like after you're done? Now, it's a math question, but it's not a math question. It's a question that you're going to answer briefly in English. You don't have to write a novel, but there must be some, after you draw these, some obvious connection between the answers to these inequality and equations you found and what the graph is showing you. And that's what I want you to describe. Describe what you see in the graph and describe how that matches the answer that you got to the algebra equation. Because remember, I'm always saying to you, graphing is solving. In a way, graphing is solving. So if you solve these successfully and you graph them successfully, you ought to see in the picture the thing that you found over here as an answer.
Okay.
And so that's a start. Try that first and get back to me if you still have a question. And then I go back to Jacob again. Which PDFs did you have a problem opening all PDFs on my site? Some PDFs?
I got that problem resolved actually.
Okay. Was it just like extraordinarily slow or you weren't connected or something?
Yeah, after like 20 minutes it was still buffering, so I just kind of quit out on it.
That is interesting. And you saw me waiting for several seconds here. I hit the reload button on these. These things are coming from Google Drive. That should not be an issue. But if it becomes an issue, if we notice that over and over and over again, I can put those files to you more directly. I could change how the website's structured, but tell me if that keeps happening. And right now, and this is neither our fault nor Google's fault nor anybody's fault. It's hard to separate what's happening from normal or new normal, but lots and lots of issues about bandwidth and speed right now in lots of places. So it's not always you, it's not always your equipment, not always me. Sometimes there's just lots of strains on the bandwidth, but that's very hard to pin down or blame or explain. So just tell me if it keeps happening to you. Anyone? Okay. Now I'm going to go back here. And there's another thing I sometimes screw up in my recordings. I got to always make sure the camera pointing at the paper is turned on. Then when I share screen, I go back and forth between that camera. Sometimes you just see the image of me, my little icon right here. And it looks like, oh, no, you don't often see me. If you want to see more, that's fine. But sometimes you just see the image that looks like a colorful blue ocean or something. I always, that's not very, doesn't teach you very much. So I try to keep the camera focused on the paper like it is now. Okay, is there any other just question you want to throw out there before we start working on equations of lines? Okay, if they come to you, just throw the questions in the chat and we'll get to them here or there. When you're working on the XYZ homeworks, you can throw the questions in the forum there or email them to me directly. People are doing that. You can just email me the section and problem you're working on, and I can find what you're working on from my side. So screenshot's wonderful. You know, if you need to, you don't always have to give me a screenshot though. You can just tell me the section number you're working on. Let's talk about line equations. So we've done a little bit of practice doing things like taking the equation of a line and graphing it. But just at a very basic level, experimenting with points. Let's say I wanted to graph this line right here. I can find lots of points that fit on that line just by putting numbers in for X and calculating what Y has to be. This is actually a good trick I want to show you. If I'm going to put numbers in for X and calculate what Y is going to be, right? I want to do it in a smart way. Well, actually, I want to do it, I want to do it in a lazy way because I don't like to work. I like to get out of work. You know, work harder, not smarter. Or no, wait a minute. I should say work smarter, not harder, right? I can pick any X I please and stick it in here. But since I don't like fractions, what X's should I pick? X's that don't create fractions for Y. So for example, if X is 2, then 1/2 times 2 is easy. 1/2 times 2 is 1. 1 plus 4 is 5. If X is 4, 1/2 of 4 is 2. 2 plus 4 is 6. Now just those 2 points alone is enough to do this problem. Because once I have 2 points, you know, let me mark them, 2 and 5, 4 and 6. Now, this is not legitimate until I toss in some scale. So never forget to mark the little tick marks and label the scale so people know where you are. But once I have these 2 points, I see The slope is up 1 over 2. Up 1, right 2. I see the slope for this line, which is plus 1, up 1, plus 2, to the right 2. That's the slope 1/2. And I see that in front of the number. Pretty soon you just get used to when someone gives you an equation like this, just saying that the slope is 1/2 right now. Slope is 1/2, positive 1/2. Up 1, right 2. And all I got to do is follow that pattern. And that would be like plugging in points. See, when I get 6 and 7 at this point, I could have plugged in 6 and said half 6 is 3 and 3 plus 4 is 7. But following that pattern, back, 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 that's like making more points in the table. Plug in 0 for x. Get 1/2 0 plus 4 is 4. But I didn't need to calculate that. I saw it right there. Minus 2, positive 3. Minus 4, positive 2. Minus 6, positive 1. After I find that key thing called slope, with any 2 points, I can just go through the whole window drawing that thing. But I want to get you out of, I didn't want you to try the point 1, not because it would be wrong to try 1. 1/2 times 1 is 1/2. 4 plus 1/2 is 4 and 1/2. It's just sometimes fractions are hard to graph. I can graph 4 and 1/2. That's not too bad. But now let me graph this. Y equals minus 7/3 x plus 3. There's no way I want to plug in numbers and generate random fractions here. So what do I do if I want to work smarter? Or if you want to say work lazier? Let's put in a number that gets rid of the fraction. For x, put in 3. Because minus 7/3 times 3, you just cancel 3 and say minus 7. Minus 7 plus 3 minus 4. That's that dot right there. Let's put in 0 for x. That's always easy to plug in 0, fractions or no fractions. That just gives you a plus 3. And do you see what you got here? You have a line that goes down 7, right 3. Down 7, right 3. That is the slope of that line, minus 7/3. Remember I said after a while, you just get used to taking that number right off there. Now, what's bad about that number? I got to go back another 3 and up another 7. I'm not going to fit more points on here. I ought to be thankful for just these 2 points, right? Yeah, but now I don't want to plug in numbers like 1 and try to figure out what 3 minus 7/3 is. I mean, I could figure it out if you gave me a second, 2/3, but I don't want to graph 1 and 2/3. You know what I want to do is graph the half points. If I go over 3 and down 7, then halfway would be going over 1.5 and down 3.5. That would give me that point. And how about left 1.5 up 3.5? That would give me that point. Now, I don't know the name of that point unless I carefully measure it and do some more calculations. But as far as drawing the line's concerned, it helps me out a lot. It helps me draw a straight line. Now, this won't be complete unless I add some scale. But I don't have to mark and label everything. I'll just go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then just to be fair to the people on the left side, 1, 2 minus 3, 4, 5 minus 6. And then below, I didn't do quite so far, just 1, 2 minus 3. There's a good graph of that equation. So what I want to say about these two pictures here is I'm going to depend from now on that if I gave you the equation, you could draw the graph. Most often, you're going to use that slope trick. Find up 2 points, do the slope, copy that pattern. But you can also use a slope and the y-intercept. Start at 4. That's where it crosses the y-axis. That's what happens when x is 0. Think about it that way. Y-intercept is the moment when you don't go left and you don't go right. Y-intercept means what point do you get when x is 0? If x is 0, y equals what? That's called the y-intercept. You can also do the x-intercept. X-intercept means you don't go up and you don't go down. X-intercept is where you cross the x-axis. And if you don't go up or down, then the y is 0. And you find out what x is. Now, sometimes the intercepts are easy to find, sometimes not. Here, the y-intercept was easy to find, and it was displayed right there too. But I haven't gone far enough to do the x-intercept. I think I could. Every time I go down 1, I go back 2. So let's go down 1, back 2. Now I'm here at -8 and 0. That's what happens when y is 0. Let y be 0, and you solve this equation for x. Well, you would subtract 4 from both sides. And then you would multiply both sides by 2. X would be -8. That's that intercept. Here, you got an easy y-intercept of 3. But if y was 0, what's the x-intercept? Well, it's between 1 and 2. What would happen if y was 0? -7/3 x plus 3. Add 7/3 to both sides. Multiply both sides by 3 and divide both sides by 7. There's the x-intercept, 9/7, 1 and 2 sevenths. You know, now that I say it, you can believe that that's 1 and 2 sevenths. But just by looking at that dot, so tiny between 1 and 2, you don't honestly know that that's fraction 1 and 2 sevenths until you solve for it. So sometimes the intercepts are both hard to find, both easy to find, one easy, one hard. But if you can locate a point in a slope, you can drive through the whole line. You can drive through the whole line relatively easily. So if I give you equations, you can draw lines. Now, how would we do it backwards? If I gave you a line picture, how would you find the equation? So you have the experience, the understanding that someone's going to put a number in front of the x, someone's going to put a number here. This number is going to be the slope. This number is going to be the y-intercept. And so this line, when people write line like this, is called the slope intercept form of a line. There's other way people write lines I've also shown you. It says, what happens if you gather all the x's and y's on one side and set equal to this constant c? If you have ax plus by on one side, you haven't solved for x or y. This is called the standard form of a line. And it's got its advantages too. I will say this, as the book says it also, when you write things in standard form, the a, b, and c are not really permitted to be fractions. So don't use fractions for a, b, and c. Also, lead with positive number. Always make sure a is a positive number. So if someone gave you the equation 3x minus 2y equals 7, this is a nice way to express standard form. There are no fractions, and you led with a positive number. But if someone wrote minus 3x plus 2y is equal to minus 7, you know, these two lines are the same. How do I know they're the same? If I multiply both sides by minus 1, which is fair, golden rule, whatever you do to one side, do to the other. If I multiply both sides by minus 1, I get minus 3x plus 2y minus 7. These are the same line. But this is standard form. I'm sorry, back up. This one is standard form. No fractions, lead with a positive. This is not standard form. I should say it in English. And people can be really, really picky about this. If someone says, write the answer in standard form, and you write like this, second choice, you're wrong. Your answer is wrong because you didn't write it the way they asked for it. But there's a good reason to be picky. It's awkward to calculate when you're leading with this negative sometimes. Same thing like this. If I write y minus 1/2 x is 6. This is not standard form. It's got 2 strikes against it. Well, it's got 3 strikes against it, actually. Got fractions in here. Standard form does not use fractions. So I could get rid of that by doubling everybody. Okay, let's double everybody. 2 times y is 2y. 2 times minus half x is minus x. And 2 times 6 is 12. This is still not standard form. What's wrong with it now? Well, standard form begins with the x part and then the y part. Don't write the y part, then the x part. It seems tiny maybe to you the first time you hear it, but you always write x and then y in that order in standard form. Okay, I'll fix that. Let's change it to minus x plus 2y. The x is negative, minus x plus 2y equals 12. What's the problem now? It's not in standard form. I'm trying to repeat this several times to drill it into your heads in a way. What's wrong with it? You don't lead with a negative number in standard form. So I can still easily fix this. Let's multiply everybody by minus 1. X minus 2y is minus 12. Now, this is standard form. By the way, I won't have to repeat this as many times. It's not even slope-intercept form. Right? Slope-intercept form is isolating the y and writing number times x plus number. This is not isolating the y. So this is also not slope-intercept form. But I can fix it pretty easily if I add 1/2 x to both sides. Now I have slope-intercept form. That is slope-intercept form. And in slope-intercept form, there's no problem with having a fraction present or even having the fraction negative. You got to have y by itself, but not negative y, just y by itself. But it's okay to use fractions and negative numbers in slope-intercept form. Why do I mention this? Because these forms are so famous that you want to instantly go back and forth between them. If someone gives you one, you got to snap your fingers and have the other. If someone gives you the second one, you snap your fingers and have the first. And I'll do a demonstration. It's not as easy as snapping your fingers, but let's go like this. 2x minus 7y is 12. This is in standard form. How do I write it in slope-intercept form? Sorry, lower the paper a bit. Actually, it just takes 2 shots, bang, bang, 2 shots. All I have to do is move the x to the other side. Correctly. And then do what? Isolate the y by dividing by -7. Correctly dividing by -7. That'll leave me a single y over here. -2 divided by -7 is 2 sevenths. And +12 divided by -7 is -12 over 7. This is slope-intercept form. And, it's kind of funny when I say it takes 2 shots to do that, bang, bang. In the past, if I talk about, it takes 2 shots to get from there to there, people don't use guns and gun language the same way they did 20 or 30 years ago, right? And I'm not advocating for or against guns. Okay. I personally enjoy archery. I like to do archery.
Do you use a crossbow or regular bow?
I use a recurve. I use the target bow.
Ah, I see.
And I just enjoy doing that. Although I think I'd like to try other ones sometime too. I think I may be interested in hunting sometime. I've never done it because where I grew up in Southern California, if you owned a gun, you were in trouble. And I didn't want to get in trouble. So the most aggressive thing I've ever done is target shooting in archery. But I do want to put this into your mind. It only takes 2 steps to turn any standard equation into slope-intercept form. Any one. And if I just describe that with 2 shots, bang, bang, that's okay with me. I'm not saying anything for or against firearms. Try it again. What if I said 3x plus 5y is 14? Sometimes it's easier, sometimes it's harder. Sometimes it's going to involve fractions, sometimes it won't. But that doesn't stop you. You just do the 2 steps. First step, get the y term by itself. Subtract 3x. And you're halfway home. Now you just got to divide by 5. Divide everyone by 5. Divide honestly by 5. Keep the signs correct. But I'm done. If I just one step at a time, divide everybody by 5. At first, you might think this is a small skill, But I want you to think about it. If I have one of the lines like this and I go to slope-intercept form, then I instantly have the slope. And slope is valuable if I'm trying to draw a line. I also have the intercept too, but intercept being ugly like this, minus 12/7, 14/5, that's not too helpful. Maybe I could find another point. I want to tell you that you could go the other way and just take 2 steps. And sometimes you want to go the other way. So let me give you an example. Like y equals 3x minus 2. And I'll just say it that way again. Just takes me 2 shots. Bang, bang. First shot, I want the x on the left side. I had to subtract 3x. But now that I've done that, it's not appropriate to lead with a negative sign. So why don't I just multiply everybody by -1? Done. No fractions. Lead with a positive. ax plus by equals c. That's standard form. Try it again. Harder one. Y equals 3/5 x minus 7. Step 1, bring the x to the left side. And that says minus 3/5 x plus y equals minus 7. Now this one's a little uglier, I grant you, but what are my problems? I don't want that minus sign and I don't want that 5. Why don't I kill 2 birds with 1 stone and multiply by -5? And I'm not saying anything about birds and hunting birds. I'm just saying it's an old expression, kill 2 birds with 1 stone. I love birds. I love watching them in the garden, the variety, the joy of their song. It's all beautiful. But what I'm trying to do is say, let's get rid of these 2 problems. Can't have a negative leading, can't have a fraction. Let's multiply everybody by -5, but let's do it just very, very carefully. -5 times minus 3/5, first of all, is going to be positive, thank you. And then 3/5 times 5, I'll just be multiplying by 5 divided by 5. I'll just be canceling that 5. So -5 times minus 3/5 is just 3x. Now I'll multiply everybody else by -5, because unless I treat everybody the same, I'm in trouble. Golden rule of equations. Whatever you do to one side, you do to the other. But this is not as bad as what I just did. -5 times 1y is -5y's. On the right side, -5 times -7 is just 35. Positive 35. You do have to be careful not to screw up the signs. You do have to be careful to multiply correctly. But all I did was take 2 shots, and I was done.
Is it okay for C to be negative or no?
Yes. Let me say that it must be okay because sometimes I might not be able to avoid it. So let me go back to my piece of paper right here. Yeah, this is a good way to say it. You are not allowed to use fractions at all. None of them can be fractions. But you can't make them all positive. That might be changing something. So I just say lead with a positive. Lead with a positive. And that's why I had to multiply this by a negative number to get rid of the negative sign and multiply by 5 to get rid of the fraction. Okay, excuse me. Okay, now sometimes odd lines come upon you. Let me show you 2 odd lines before we get to actual equation making. Here's an interesting line. Y equals 3. What do you think about that red thing? Is it a line? Well, it's straight. Sorry, move the paper up. It's certainly straight. It looks like a line. Y-intercept of 3. Put some scale there. But it doesn't look like a line in this sense. You're thinking of lines as slope plus intercept. I see the intercept is 3, but I don't see the slope. But
There
you
wouldn't be a
could,
slope.
go ahead, say that again.
There would be no slope. It would be 0, right?
You just said two different things. This is really important. That's why I was trying to goad somebody into saying that. You said there was no slope, and you said the slope would be 0. This is very interesting. In English, those two things mean the same. How much money do you got in your pocket? I got no money in my pocket. How
12
much money
cents.
do you got in your pocket? I got $0 in my pocket. The proper word for this problem is that the slope is 0 because I do not go up and I do not go down. 0 slope means perfectly flat. When you say slope is 0, then you are saying it is perfectly flat. If you say no slope, what you mean is that line. This line is all the points where x is equal to 2. And this is also not in that form. But there's nothing I can do. I can't even pretend it has 0 slope, because what's the slopeness here? I go up 3 and I go right 0. And there's no such number. I can't say slope is 3 over 0. I can't divide by 0. So this is very particular in lines. When you say no slope in a line, you mean you're talking about a vertical line. And when you say 0 slope in a line, you mean you're talking about horizontal line. But as far as making their equations, they're pretty easy to make equation, because if you got a vertical line going through x equals 2, you just write x equals 2. You're just telling people where it is. Where is it? It's at x equal 2. It's the collection of all the points that begin with a 2. How about if someone gives you this red line and says, describe it to me? You say, no problem. Y equals 3. Why is that? Because it's the set of all the points in the plane that have a y coordinate of 3. So those two lines are special. They're in their own category. Horizontal lines is y equals some number. 2, 7, minus 4. Vertical lines, that means straight up and down. That means x equals some number. I just write this here. Some constant. Okay, got it. The only trouble is sometimes people think horizontal means x-axis. Well, the horizontal axis is the x-axis. But the x-axis is the place where all the y's are 0. So horizontal line means y equals constant. Vertical line means x equals constant. Do not mix those up. Okay, one more thing, and then we'll take a short break. So I was just making you, or trying to make you, very good at recognizing equations, manipulating them. I didn't ask you to draw any of these, by the way. That was what we did last time. I think if I gave you these and you worked on finding some points in the slope pattern, you could draw them. But I didn't ask you to draw these. I just wanted you to manipulate them. because to show you how to create these equations, I have to show you how to manipulate them from one form to another. So let's create our first equation. Let's say I give you the line that goes through, I don't know, minus 2, 2, and 4, 5. I just pick some points out of the air. I pick points that turn out to be nice, but we'll try weirder ones in a second. Let me mark some scale. I can put the numbers on the left or right side. I can put them above or below, whatever looks good for your drawing. You find me the line through those 2 points. Well, can you find me the slope? How far do you go over and up? That would be the first job. Slope. I went from minus 2, 2 to 4, 5. How much did I go up? I went up 3 steps. How much did I go to the right? I can go left or right, but in this case I went right. How many steps? 2, 4, 6 steps. And so the slope there is 3 over 6, which is 1/2. Now notice you could have done that by subtracting the points in order. 5 minus 2, that would be one y value minus the other value. And then 4 minus negative 2, respecting the negative signs, that would be one x value minus the other x value. In order, that still gives you 3 over 6, which is still 1/2. You also understand I could have said I go down 3 and left 6, because to go down 3 and left 6 is also a ratio of 1/2, because negative divided by negative is positive. Okay, what do I got? I got a 1 to 2 ratio, and that kills this line. That means I just keep going the up 1, right 2 ratio, or down 1, back 2 ratio. And you see when I do that, I get a free gift right there. I landed right on a tick mark. 0, 3. The y-intercept is 3. Well, now I know the equation of that line. The slope is 1/2. The y-intercept is positive 3. Done. Remember, that's slope-intercept form. What if someone wanted standard form? Remember, I'm not afraid of that. Just 2 shots, and I'm done. 2 shots. Subtract 1/2 x from both sides. And now I got to get rid of this minus 1/2. Let's multiply everybody by minus 2. Minus 2 times minus 1/2 is positive 1. Minus 2 times y, minus 2y, minus 2 times 3, minus 6. Before we go to break, let me say this, because sometimes people diss the standard form. Sometimes people don't respect the standard form. Let me show you what the standard form is excellent at. Do I give you a point here, like 6 and 6? 6 and 6 is a point on this line, apparently. So is 4 and 5. But if I ask you, is 6 and 6 on this line right here? It's not impossible, but you just get distracted by the fractions. So you take the y is equal to 6. Is that the same as 1/2 of 6? The x is equal to 6. Is 6 equal to 1/2 of 6 plus 3? Is 6 equal to 3 plus 3? The answer is yes. This is a good point. But I want you to try it here. Is xy equals 6, 6? On this line, you know it's so easy to test points in standard form. That's why people love standard form. At least that's one reason. So put 6 and 6 in here. What do you get? 6 minus 12, negative 6. Done. No fractions. No strange calculations. So standard form is a great form for calculating or checking points. Slope-intercept form is a great form for drawing. But you can use either one because you know how to go back and forth. 2 shots. 1, 2, 1, 2. Okay. Here's the first example. I gave you a picture. You found the line. What if I didn't even draw the picture, but just said, I want the line to go through minus 2, 2, and 4, 5. There's nothing stopping you from drawing a picture, but you don't have to draw a beautiful picture to get the answer. So let's check this out. Right now I got 1 o'clock. Let's say back at 1:05. And we'll try harder and harder equations. You know, harder, giving you less information, more mysterious information, and seeing if every time we could still construct the line. And we will. Take a break, stretch your legs. I'm going to mute my microphone, stretch my legs for a second, and we'll be right back. Okay, we're coming back together here. But maybe this was too easy to be given a picture. Did someone giving you a picture make it too easy to calculate the line? I don't know. It could be bad still. We certainly got a break when that line crossed right on the mark. What do we do if that doesn't happen? What do we do if we have no picture at all? Let me fold the paper here so I can keep this picture in front of your mind. What if someone just said, find the equation of the line through minus 2, 2 and 4, 5. Now, again, no one could stop you from drawing a picture. But what if they didn't give you a picture to work with? Could you do it without drawing a picture? And the answer is yes, you can. Because you can use the idea of slope. You know, pretend this is x1, y1, and pretend this is x2, y2. And you know the slope is just the change in the y. Did you go up or down? Divided by the change in the x. Did you go left or right? Here, if I plug these numbers into that formula, I get 5 minus 2 is equal to 4 minus negative 2. But that'll be the same no matter what point. You know, back to the picture. No matter what 2 points I pick, I get slope 1/2. Whether I go left or right, I get slope 1/2. So think about it this way. What if there was a mystery point on that line, and I don't know the name of that mystery point yet? What would be, if you like, you can call this x naught, y naught, but why don't we just call it xy? What would be the slope between xy and 4, 5? What would be the slope between xy and 2, 2? What if I went from x, y to 2, 2? Let's say I can subtract in either order. Y minus 2 divided by x minus negative 2. If this point is on the same line as these two, it has to produce the same slope. We got to get the same slope. Same slope means these two numbers are equal. Here's a number on this side. We already know that number is 1/2. It's 3/6. On this side is not a number, but it's a fraction, y minus 2 over x plus 2. I'm interested in solving for y. I want the slope-intercept form. So what could I do to both sides? Remember the golden rule. Whatever you do to one side, do to the other side. And one of my other favorite rules is get rid of fractions whenever you can. So let's multiply both sides by x plus 2. On the right, that cancels the x plus 2, and I just have y minus 2 left. On the left, I have 1/2 x plus 2, which is, take it over here, y minus 2, is 1/2 x plus 1. Now let's isolate y by adding 2 to both sides. Y is 1/2 x plus 3. There's a line. It is, if I fold this over properly, I can't fold it over perfectly, the same line as I had a second ago. Now this ratio thing is hard to express, but what I'm really saying is that the slope is equal to y minus a point on the line, y1, x minus x1. And I can call this points anything I like, x1, y1, x naught, y naught. What I get, if I do this in general, is I get another famous line equation. It's called the point slope form. I'm going to add this to my pantheon of equations. My pantheon is like the Greek pantheon is like all the different gods they had in ancient Greece. So I'm not even going to use the word worship. That's not the right word. I'm going to admire famous line equations. There's a slope-intercept form. Great for graphing. There's the standard form. Great for calculating. But then there's another form that's great for creating line equations. And that's called the point slope form. If you know the slope and you know a point on the line, then this equation will give you the equation of the line. Let's try it. Find the line with slope negative 2/3 through the point minus 5/7. The negative 2/3 is my slope. That's the M. The minus 5/7 is my sample point, my starting point, x naught, y naught. All I have to do is plug those things into this equation and legally manage all the negative signs, all the multiplying, and I'll come up with the right line. Let's try it. Y minus 7 is equal to negative 2/3 x minus x naught is negative 5. Respect the sign. That's really x plus 5. If you're not in a hurry, you don't have to be in a hurry, just clean this up slowly. Minus 2/3 x plus 5 inside. Now let's multiply everybody on the right by 2/3. Minus 2/3 x, a little bit annoying to drag fractions around, but negative 2/3 times positive 5/1 is minus 10/3. Now I can have the slope-intercept form if I add 7 to both sides. But I've got these crazy thirds right here, right? So I got to turn 7 into thirds. 7 is 21 thirds. 7 is 21 divided by 3. So if I have negative 10 thirds plus 21 thirds, what I got is what? Net positive 11 thirds. Okay, remember, this is slope intercept form. Am I right? Well, there's a little bit of a problem there, isn't there? I am right as far as I got the same slope. I got the right slope. In order to make my line correct, it better have the same slope and it better go through that point. But you know, checking the point in here is a serious pain. I don't want to talk about thirds. So why not go to standard form? Add 2/3 x to both sides. I'm not saying you can't check it here. I'm just saying I hate fractions. Let's multiply everybody by 3. Now I've got standard form. And let's check it out. Oops, if I multiply everybody by 3, I better multiply everybody by 3, and that includes the y. See, that's the danger when you're just doing things and talking at the same time, or doing things and not writing it down. 3 times 2/3 x is 2, 3 times 1y is 3y, 3 times 11/3 is 11. Okay, now let's try the point minus 5, 7. So sweet in here. It's like negative 10 plus 21. Negative 10 plus 21 is 11. Got it. I got the correct slope. I got the point on my line. I will answer any way they tell me to answer, but I know the equation. I've got it. So this point slope form is kind of like the equation maker. The equation maker. Let's try a harder one before we go on. Let me really make this bad. I mean, let me make this ugly. I mean, but no matter what we do, someone will come up with an uglier one. But let's try find the equation of the line perpendicular to, I don't know, 2x plus 5y equals 6 through let's get really crazy. Through the x-intercept of y equals negative 2x plus 7. I think I made it worse than I intended. But I want to say this. In the end, you are the line master. And no one can really hide a line from you. Here's your equation. And if you find a slope, and if you find a point, you're going to succeed if you do the arithmetic correctly. Why did I call this a nasty one? Because your first reaction is, what's the slope? Where's the point? I didn't give you either one. I didn't give you a slope or a point. But then you got to think to yourself logically. No. If he asked me the question, he must have given me what I need. Now, I admit that sometimes people can make a mistake and ask you a question that's a bad question. But let's just take it right now that I'm not trying to trick you. Book's not trying to trick you. So if they ask you the question They did give you what you need, but not maybe the way you wanted it. Let's remember this. Remember perpendicular, the word we used last time? Perpendicular slope is when you have a slope like 3/5 and minus 5/3. What is perpendicular slopes? Negative reciprocals. One slope is m, and the other slope is minus 1/m. So I want to be perpendicular to this person. If I can find the slope of this person, I think I can make it perpendicular. So let's do that. Find slope of 2x plus 5y equals 6. This is why I want to transition 2 shots to the slope-intercept form. I will subtract 2x. I will divide by 5. And now I know the slope of this person is minus 2/5. But that's not my slope. My slope is perpendicular to him. This is the wrong slope. I want the slope that this is perpendicular to. So what slope is this perpendicular to? Negative reciprocal. If this line has a slope of minus 2/5, then my line must have a slope of 5/2. Okay, so they did give me a slope, just not the way I wished it.
Professor, I have a question.
Yeah, go ahead.
I'm not sure if it matters or not, but when you divided 5 for finding the slope for the first equation, was that supposed to be 6/5?
My goodness. Yeah, I got to do that. I got to be honest and do it properly. Even if I didn't use it, I better do it right. Thank you. Good point. Okay, so they did give me a slope, just not the way I was looking for it. Now, did they give me a point? In a way they did right here, x-intercept. What is x-intercept? X-intercept is where line crosses the x-axis. It's the moment when y is 0. This line doesn't look like that. I'm just giving you the idea. So can I find the x-intercept of this line? What is the x-intercept of y equals minus 2x plus 7? I set y equal to 0, and now I solve for x. 2x is equal to 7. When I add 2x to both sides, x is equal to 7/2. That means that that line crosses the x-axis at 7/2. They did give me a point, just not in a pleasant way, in a sneaky, underhanded way. But I don't know if it's sneaky. I mean, they couldn't hide it from me. I found it. Okay, now let's go to the equation. If you get the slope and the point, you're going to get this equation right if you just do your arithmetic correctly. Y minus y naught. Well, there's a gift. Y naught is 0. Equals m, which is 5/2, x minus x naught. Okay, there's going to be some pain in here somewhere, right? Like, okay, I don't want to use fractions, but sometimes I can't avoid it. So let's just work through very carefully. This at least is nice. I've already got y by itself. I'm going for slope-intercept form right now. 5/2 x. And now 5/2 times minus 7/2, multiply numerator, denominator, minus 35/4. Now, I want to take that line just as it is. That's a slope-intercept form. But in case I got some people out there that like the standard form, we can do that too. I prefer the standard form because the standard form can help you do lots of calculations quickly. Maybe later we'll do some examples like that, but right now I just want you to be equally good at both. Subtract 5 halves x from both sides. Multiply both sides, every single person, by -2. Oh, that's not going to do it, is it? You know, I could do that minus 70 over 4, which is minus 35 over 2, minus is plus. You know, that's not quite standard form. I don't think multiplying by -2 was smart enough. What if I multiply by -4? Because I don't want any fractions. Multiply this by -4, much nicer. 35. Now, I haven't used a calculator enough today, or enough at all. But I want to show you something sweeter. I have mentioned Desmos to you a couple times. Let's take this problem to Desmos, because Desmos graphs lines really nicely and simply. So, oh, excuse me. I have to share my browser here with you. I didn't do that. So let's go back to just a web page, and I'm just going to open a new tab and type desmos.com. Remember, I showed you, you could create an account here if you want to share stuff with me or with someone else, or you can just graph. Let's just graph. What was the line we were given? We want to be perpendicular to that. 2x plus 5y equals 6. And do you know Desmos just graphs the line 2x plus 5y equals 6. It doesn't need slope-intercept form. Although you can check that this is going down 2 and right 5 to get to 3, 0. So you could check that this does match the slope of this line. You know, if I solve that for y, I would say y equals minus 2/5 x plus 6/5. Like you pointed out to me, I had to divide the 6 by 5 also. So do you see that? Whether I write it in standard form or slope-intercept form, I get the same line. What's cool about Desmos is you can decorate with different colors, or you can decorate by having dotted and non-dotted. So I've got the same line any way I strike it. Now let's type in the line that we calculated, which was first in slope-intercept form. 5 halves, which is the reciprocal of minus 2/5, good, x minus 35 over 4. Check that out. This looks like right angles. Now, maybe my screen is not beautiful right angles. So go up to this wrench up here. And can you make the, oh, I saw it there a second. I missed it. Sorry, zoom square. That'll make the window perfectly 1-to-1 units. And now you see the green line and the red line are perpendicular. You can turn lines on and off just by clicking the colored circles over here. Does this green line have a slope of 5 over 2? Yes, it does. Because it's perpendicular to slope minus 2/5. Does it cross the x-axis at 7/2, which is 3.5? Let's zoom in. It crosses 2 to 4. Here's 3. Zoom in again. It crosses exactly halfway between 3 and 4 at 3.5 and 0. That's another nice thing about Desmos. If you just click on a point, you get the name of the point. How about if I want to know where they intersect? Well, approximately at that point. Your calculator will do all kinds of things like find intersecting point, but it doesn't just let you click on the screen or touch screen. So if you're looking for a quick check on your problems, did it go through the right points? Is it perpendicular to the line he gave me? Is it parallel to the line she gave me? Desmos is just very easy to type and go. Even the standard form, 10x minus 4y equals 35. Same line, got it. Same line. Crossing at 7/2, 3.5 and 0. Okay. Play around with Desmos because it'd be worth your while. It's kind of actually, and even if you're doing pictures for me on a homework, maybe in the future, you can. Okay, we're back here. I think we just had some kind of like natural disaster. People hear me. Can someone check in? You picked up do you have the audio here? Let me turn that up. And I see the message. Thank you, Benito. I think I described this to you once. If the internet goes wacky and we get dropped from a meeting, Zoom will try to reestablish you in the meeting. So somehow I think internet cut out on me for a second, but it came back and reestablished it and reestablished you all in the meeting. Okay, sorry about that. And I am still recording. So what happens when I get dropped out of a meeting? Do I get 2 separate recordings? I guess I'm gonna have to go find out when we're done. Okay, so Desmos is a great thing to try. Let's move on to another topic though. So you can draw lines, you can get the equations of lines, you can figure out parallel and perpendicular. Parallel is a little easier. If you want to be parallel to someone, you just use the same slope. Perpendicular is the one people forget. They usually forget to have the opposite signs. You know, they flip over the fraction, but they forget to say opposite sign. So if you have one slope, then perpendicular slope, you have to do both. Change the sign and flip it over. By the way, what's perpendicular to 3? Change sign, no problem. How do you flip over 3? 1/3. What's perpendicular to 1/2? Negative. Change sign, make it positive, no problem. Flip it over 2 over 1, but just say 2. So positive 2, negative 1/2. So remember, when you do perpendicular, you change the sign and take the reciprocal. So there's lots and lots of lines you can practice on the handouts I gave you or problems in these sections. Let's just spend a little time talking about the next section here. It's just a gentle introduction. I got to get rid of that other window. I'm back. I'm back. Sometimes this word gets a bad reputation. Function. Function. You know, how do you use it in English? Your gas mileage is a function of how fast you drive. Although I don't think, maybe some of you have said that your gas mileage is a function of how fast you drive. You know, by the way, and I don't advocate this because I don't want you to have an accident, but you're running down the road 70, 75, maybe more. You're burning a lot of gas. If you were driving and it was safe to do so, and you're not going to use a lot of time, drive between this city and that city on the freeway at 60 miles an hour or 65 miles an hour. Even if you did it 65 miles an hour, first you get a lot of bad looks from people. So don't do it if it's too busy. But if you drove 1 week at 65 miles an hour compared to what you normally drive on a freeway, you would cut your gas by a third. Cut your use of gas. You save a lot of gas. You know, that's not always possible sometimes, especially don't create a hazard by driving 60 miles an hour on the freeway if you got traffic, right? But you'd be surprised how much your gas mileage depends on how fast you drive. So your gas mileage is a function of how fast you drive. But most people don't say it like that. Most people say, my gas mileage depends on how fast I drive. They use the word depends. What else could I say? I'm trying to make up some simple example that's not silly. Oh, the number of games the Tigers win in a year depends on the ERA of their pitching staff. I don't know if anybody out there is Tiger fan. I was willing to give them a shot this year, but somehow their pitching is not there. It's just not there. They got some hitting, okay, but their pitchers that are supposed to come through, they're just not coming through. So wait till next year, Tigers. But I could say that the amount of games the Tigers win is a function of how good their pitching staff is. And it's a function of how good they hit. It could be a function of many things, but function in English, we kind of say depends on. We also use function in English like this. A function is what someone does. What's your function? My job is to cook in their restaurant. My job is to, clean the tables. How does that thermostat function? Means how does it work? What does it do? What does it do? How does it work? Now, we were very happy in these last 2 days that we could draw pictures of lines just by saying, I put in a value for X and I can create a value for Y. And I'll draw this one very quickly. Always put in the easiest points you can, by the way. Put in X equals 0, you get Y equals -4. That would be the Y-intercept. And then I see a slope of 3, up 3, right 1, up 3, right 1. I can do that all day, but I can just plug in 1 and get -1, plug in 2 and get 2, plug in 3 and get 5, plug in 4 and get 8. There's my line. You know what I want to say to you though, and I had to put scale here or else it's no good. Never, ever draw anything without marking scale. So on the homework you're handing in tomorrow night, I've already pre-marked the scale for you. If you draw something without scale on any other assignments, I will probably subtract 1 or 2 points because it's not worth anything unless you tell me what the scale is. It'd be like trying to drive down the freeway and somebody removed all the mile markers. You'd go nuts. You know what I want to say when I look at this picture? 3 and 5, 2 and 2. 1 and -1. I want to say when I look at that picture that the y value depends on the x value. The y value of each point depends on the x value. So in the same way you used function to mean depends, in math, people use the word function and say the y value is a function of the x value. And it's true. The y value does depend on the x value. The y value is dependent on the x value. The y value is a function of the x value. Now, because they invent this new word, there's got to be some kind of punishment. They invented a new notation too. When you want to say in a mathematical shorthand, the y value is a function of the x value, you say it like this: y equals f of x. That's the mathematical shorthand. And if you want to read this or pronounce this, you say it just like that. Y is, equal sign means is, f of x. That is a shorthand for y is a function of x. So when you see this, you read it, y is a function of x, or y equals f of x. And here's how I'm going to do it for this line. I go back to my questions. What does it do? How does it work? So if I said to you, y is a function of x, and you would say to me, well, what does it do to x? And I'll tell you what it does to x. What does f do to x? It triples it, and it subtracts 4 from that. Now, this is a little bit underwhelming when you reach this point, because someone in the audience invariably says, you mean you just wrote f of x instead of y? Is that what you're saying? And the answer is yes, I did. I just wrote f of x instead of y. But do you see, it's a different style of communicating. I'm going to tell you what this f does to x. It triples it and it subtracts 4. And then do you know how you would answer someone if they said, well, then what does f do to 2? What does f do to 2? And you say, well, it triples 2 and then it subtracts 4, which results in 6 minus 4 is 2. So f of 2 is 2. That's right. Y equals 2. If I say to you, what does f do to -1? You just keep responding the same way. What does f do to -1? What does f do to anybody? Triples them and subtracts 4. And that results in -3 minus 4 is, I didn't need the parentheses there, sorry. -3 minus 4 is -7, which doesn't fit on my screen, really. It's kind of down here. But that's how you read that. When someone says, let me get weirder. What if someone says that G does this? Let me invent something crazy like x squared plus 5 over 2x minus 1. And by the way, when you talk about a function, you don't have to use f all the time. You can use any letter or name you want. You could call your function tree if you wanted to. You could call your function yellow if you wanted to. You call functions by their names. And in math, people just have a habit of using single letters for the names of functions. And most often they use letters like F and G and H. But you can use any name you want for a function. You could call it d of x. But no matter what you call it, if someone says, okay, what does it do to 5? Then I have to follow the instructions. It squares the 5. It adds 5 more. And then it divides by 2 times 5. Subtract 1. There's a little work to be done here, but this is 25 plus 5. The bottom is 10 minus 1, 9. So what does G do to 5? It turns it into 30 over 9. Now I can simplify that, divide top and bottom by 3, turns it into 10 over 3. And I want to create, in just a few minutes left, I want to create a crazy picture in your mind. You're used to lines and equations of lines after you've done the practice we've done in the past couple days. But if I'm telling you the truth, that every equation creates a picture, I wonder what this equation looks like. And I wonder if I plugged in the 5, would I see the 10/3? Now you could type this equation, again, directly into your calculator, but I'm going to go back to Desmos because Desmos is so nice for just typing things in. Back to my website, I had Desmos open in a tab here. Let me eliminate these things that I had done. And let's type in, I could type it in just like I wrote it on the paper, g of x equals. And then I use parentheses for numerator and x to the second power plus 5, stop, divided by 2x minus 1, stop. Now, I have the numerator and denominator here naturally. I don't need the parentheses per se, right? And you say, where's the picture? Now, I may have a bad window right here. So it's like calculator, I need to find a better window. But Desmos, I'm just going to zoom out. Whoa, there's the picture. Notice it's not a line. But if I was to ask Desmos, what happens to 5? Let's ask Desmos, what does G do to 5? Desmos responds with a 33333 stuff, which I don't like. I'd rather have 10/3. Look at the little circle. You see the box over box? Click on the box over box, 10/3. Desmos will actually tell you the fraction. Can I see this fraction on the screen? 10/3 is about 3 1/3, right? So maybe I'm right here, but I'm a little bit off. How about if I did it this way? Let's type in 5 and 10/3. Desmos puts a red dot right there. let's type in 3. And I don't have time to put in the 3 to the formula. Let's type g of 3. Desmos puts a blue dot right there at 3 and 2.8. What does g do to 3? Turns it into 2.8. Would you rather have a fraction? 14/5. Desmos is really underrated. It's very powerful, very easy to mark points or draw equations. Now, later in this course, and not for several weeks, I'll show you how to draw this g of x by yourself. But it's not bad to have a computer or calculator confirming it for you. So I just wanted to show you something that wasn't a line, just to let you know that for the rest of your life, you're not drawing lines. Every equation creates a picture. Every equation creates a curve, a graph. And the more equations you learn, the more pictures you learn how to draw, the stronger you are. So I have no problem if you want to draw something and check it on Desmos. I have no problem, unless the problem says draw it by hand or draw it yourself. You can use Desmos to generate graphs for us or for the homework problems. Okay, I'm going to let you go there. I haven't done a lot of things with function. We'll come back and do more. But I just want to make function not a mysterious word to you. Oh, sorry. Let me go back to my paper. Function means depends on. Function means what does it do? I am a lawyer. That's my function. Or I am a pitcher. What do you do? I play baseball. What do you do? I'm a pitcher. Tigers need you. Call the Tigers. How does it work? I think my engine light is on. I think my oil pump is broken. Whatever. Don't ask me to fix your oil pump, because I'll just look at you and say, how does it work? I don't know. Function is a very ordinary word, but in mathematics, it just means one value depends on another. Okay, it's not a bad day outside, not too cloudy, reasonable temperature. You guys go outside and you have some fun. And I'll figure out what happened to our recording after that little blip, but I don't think any serious damage was caused. I'll talk to you guys again on Thursday. You guys have a nice day.